Hey, this is Mrs. Smith. Today's tutorial is going to be over balancing chemical equations. That was one of the lowest objectives on our district assessment. So first, I'm going to start off with the law of conservation of mass, or it can be the law of conservation of matter. The law of conservation of mass states that matter cannot be created nor destroyed during ordinary chemical and physical reactions. So whenever we have a chemical change, we start off with something on one side, it goes through a change. The other side is going to have the same mass, it's the same amount of matter, it is just rearranged. So let's say we start off with hydrogen molecules on this side, and we have oxygen molecules. When they combine during a chemical reaction, they yield or they produce, now they've turned into water molecules. But it's not, nothing was created or destroyed, it's just rearranged. The same things are still on both sides of the equation. Okay, so now let's practice how to see if an equation is balanced. That's what you have to know for 8th grade science. So I'm going to do, well, let me read the question first. Which of the following equations is in accordance with the law of conservation of mass? That means it has to be a balanced equation. So let's take F first. Okay. I'm going to write it over here just because I need more space. So this is the reactants on this side. It's going to yield or produce. These are the products. Okay. So whenever I balance the equation, whatever elements are on the reactants has to be the same elements over here in the products. So I see Fe is iron. I'm going to put that underneath the arrow. The next element I come to is oxygen. I'm going to put that underneath the arrow because this is like the equal sign. It separates both sides. Both sides has to be equal. Now to see if it's balanced, I'm going to look at iron on this side. I know that this is the coefficient. So there's 2 irons here times that 2 is 4 on this side. So there must be 4 on this side. I see 2 on this side. So I can stop right there. F is not balanced. If one element isn't balanced, the whole thing isn't balanced. But just for practice, let's look at oxygen. Oxygen O3, but times 2, there's 6 oxygens on this side. Let me check the other side. 3 times this 2, there's 6 oxygens on this side. So the oxygen element is balanced, but since the iron element is not, the whole thing isn't balanced. Now let me go back a little bit because I think some of you were confused on how to count these formulas. Okay, so this big number in front, the coefficient, means that there's 2 of these. So there's 2, let me scratch that out. Fe2O3s. I think that's iron. No, that's not iron oxide. But there's 2 of those. That's one of them. Here's the second one if I want to write it out. So now Fe2 here plus those equals 4 Fe total. That's where I get that 4 from right here. On this side, this big coefficient means there's 2 of these. So that's 1, that's 2, or 2 times that 1 is 2. Okay, so that's that one. So on for this particular question, I would need to work out each one of these to see which one is balanced. I'm going to skip down to J. And actually, oh, I'm just gonna, since I have space on this one, I'll work it underneath. I see C, carbon, hydrogen. See how I write my elements underneath the arrow? O is oxygen, and so I should have those same elements on that other side. Let me count my carbons on this side. This subscript goes with the one in front of it, so there's 2 carbons. Make sure there's no more over there. Over here, there's 2 carbons. There's no more carbon, so carbon is balanced. Now let me check hydrogen. Here's 4 right here. Over here, 2 times that 2 is 4. So my hydrogens are balanced. Now if my oxygens are balanced, then the whole thing is balanced. 3O2 means there's 3 of these. So 3 times 2 is 6. On this side, now be careful because I can't stop here. Here's 1 oxygen. 2 times this 2 is 4. But I have to make sure I look at the whole equation. Here's another oxygen right here, and that's 2 times that 1, 1, 2. So it's balanced. So since each element is balanced, this equation is balanced. Your answer should have been J. So in chemical changes, no matter how big the bang, mass is neither gained or lost. What's on one side before the reaction is the same thing after the reaction. So until next time, I'll be back.